Welcome back, everyone. I am absolutely thrilled to have you here for today's explainer. We're looking at a topic that starts with something you've probably seen scrolling on social media, but it ends up challenging our fundamental understanding of reality itself. We're taking this dramatic, viral video of a tree exploding from a lightning strike and using it as our entry point into a wild, mind-bending theoretical physics framework proposed by Dr. Ahmad Rihan. We're going to see how a single, shattered tree might just be the key to unlocking a unified theory of the entire universe. Okay, let's dive right into this. Here is our roadmap for today. We'll start with the exploding tree mystery, compare the standard model to Dr. Rihan's theory, explore the three Faraday limbs, zoom into atoms, strings, and waves, and wrap up with the future implications. So, part one, the exploding tree mystery. Picture a severe thunderstorm. The air is thick, the sky is dark, and suddenly a massive lightning bolt strikes. But here is the central question we have to ask. Why did only this specific tree shatter? In the video analyzed by Dr. Rihan, one single tree is absolutely obliterated. Yet, trees of similar height and moisture right next to it, they are completely untouched. This tree wasn't just burned, it was violently dissociated. Shattered into debris in mere seconds. If you slow the footage down frame by frame, this fascinating 1-2 punch emerges. First, you get this invisible magnetic spark, and then, a split second later, a massive, destructive flash. It's an incredibly precise event that literally vaporizes one target while sparing everything else around it. Moving on to part two, the standard model versus Rihan's theory. Now, what's really interesting to consider is the contrast in how we view this. Conventionally, textbook physics says lightning is a massive, somewhat random electrostatic discharge. Clouds just dump up to 200,000 amps of current, boiling the tree's sap until it explodes. Basically, the tree is just a passive victim in the wrong place at the wrong time. But Dr. Rihan's framework proposes a really wild alternative. He argues the tree is an active participant in a targeted, multi-phase circuit delivering energy with absolute precision. Which brings us to part three, the three Faraday limbs. Rihan suggests this whole self-organizing process relies on Faraday's laws of induction, breaking down into three specific steps. Step 1 is a leader, an unseen magnetic spark reaching down from the sky. Step 2 is a streamer, a visible discharge reaching up from the earth. And step 3? Well, the tree itself acts as the exact geometric key, or what he calls the third Faraday limb, required to close the circuit. The neighboring trees were spared simply because they didn't fit the lock. Let's zoom in even further for part 4. Atoms, strings, and waves. You might be wondering, how does the actual sap and wood do this? Well, Rihan starts by modifying the classic 1913 Bohr model of the atom. Instead of those isolated little planetary systems we learned about in school, imagine these atoms sort of awakening under energy input. They inflate into ball-like structures, reaching out to form their own miniature Faraday limbs, actively preparing to join this massive closed circuit. Standard quantum mechanics tells us a particle exists in a wave of probabilities until it's measured. Rihan links this idea to the Banach-Tarski paradox, suggesting wave functions actually duplicate to probabilistically seek a path. When that tree completes the circuit, it triggers a massive, coordinated multi-collapse of wave functions. It's like a giant puzzle snapping together. The shattered wood is really just the macroscopic aftermath of this huge quantum event. And this takes us all the way down to fundamental string theory. Usually we think of strings as purely abstract math, vibrating loops in hidden extra dimensions. Rihan completely flips this. He reimagines strings as observable, real-world access for energy flow. The lightning's energy literally spirals down these physical strings from the sky, and when the tree aggregates too many of them, the density causes that violent dissociation. And this brilliantly illustrates our entire zoom-in journey. At the macro scale, a seemingly random lightning strike is actually a targeted three-limb Faraday circuit. Microscopically, isolated atoms become active circuit participants, and fundamentally, abstract string dimensions become observable energy axes. This framework is attempting to unify all three scales of reality, all based on observing a single lightning strike. Finally, let's look at part 5, implications and future testing. If lightning truly seeks specific geometry, the real-world applications are massive. We could engineer third-limb mimics to safely attract and redirect strikes, totally revolutionizing infrastructure protection, or even develop Faraday systems to capture this as renewable energy. However, we do need to remain objective here. This is highly theoretical. It requires rigorous, formal mathematical development and empirical validation, things like high-speed multispectral imaging, before it becomes textbook science. So, the crucial point is captured perfectly in this source analysis. The lightning tree is not destruction by chance, but a vivid illustration of innovative physics in action. Whether or not this unified theory ultimately passes rigorous scientific testing, it offers a fascinating paradigm shift, right? It challenges us to look at a chaotic storm and see profound, self-organizing structure instead of just random noise. It leaves us with one final, huge thought. Does the universe operate by random chance, or through beautifully interconnected targeted circuits? The next time you see a storm roll in, I bet you might just look at the lightning a little bit differently. Thank you so much for joining me, Focus Learners. Keep questioning the reality around you, and I will catch you in the next explainer.